All right, welcome to Roots of Reality Experiences. Today I'm joined by Dr. Abel Mendez, who is a planetary astrobiologist and director of the Planetary Habitability Laboratory at the University of Puerto Rico, Arecibo. His research focuses on the habitability of Earth, the solar system, and exoplanets. Additionally, he also leads the Arecibo WOW project, an initiative established to analyze unexplained radio signals from space in the search for extraterrestrial intelligence. So, Dr. Mendez, thanks for coming on today.
Oh, thank you for inviting me. My pleasure.
So, just to start off, curious how you first got interested in astrobiology and just the search for life and space in general. So,
So I think that everybody is interested in astrobiology somehow.
true.
So especially in their childhood. So
Yeah, yeah.
it started in my childhood, and I always love astronomy. I wonder, and I have a telescope, a small telescope, and then a computer also. That was in the 80s, so there were not many portable computers at that time.
Right.
So so through time, the only thing that changed was that my computers were getting smaller and my telescope was getting bigger.
Yeah,
So I decided just to go that way, studying physics and then astronomy. And once I started at the university level, which you can do your own research field, then
sure.
I decided, yes, let's go to the passion. Let's go to the astrobiology. And I think the motivation for that was probably 1996 when I started teaching at the university. That year, there was also the big announcement of the potential biosignatures in the Martian meteorite
Ah,
the
okay.
NASA was announcing. So that probably that pushed me more into
Yeah.
doing that line of research. And after a few years after that, about 1998 to 2000, then NASA announced the Astrobiology Science Conference, and I got
Okay.
hooked on that, and I just went to the first one. And there
Yeah.
were not many people down there, probably 500 or so, and there was only one session, no
Wow.
multiple sessions. So that was the beginning. Then those conferences are now every 2 year by NASA, and they're in the 3,000 per
Yeah.
person. Hmm.
How has your perspective on this idea of looking for life in space changed from when you were first interested, and preparing to go to college versus, after getting into the field and seeing how things work and everything else?
I think that also that's like everybody else that at the beginning thinking, well, the possibilities of life out there should be very high.
Yeah,
The
yeah, yeah.
universe is big. There should be something out there. That's the easy take on that.
Right.
But once you start to study astrobiology, I mean astronomy, the biology part,
Sure.
then you become and start recognizing that life is hard for many reasons. There's astronomical reasons that the planet has to be formed and be in the right distance and the right atmospheres, and there are many life-threatening events like impacts or radiation from other stars, or something could go wrong at any point, that you start to amaze that we're here. But then
Yeah.
you also understand the biology and see how complicated is biology, starting for a single uh, cell to becoming a multi-cell life form, and then become animals, and then those animals become intelligent, and something go wrong in the planetary scale or the local level.
Sure.
So so at some point, I got amazed and say, "This is huge." And I probably got my focus on astrobiology. It was searching for life, searching for extraterrestrial life. Yes,
Yeah.
that's what I love. But the more I learn, the more I appreciate our planet. And now, even that I do that, is not. I don't think that's like my focus. I am more like looking for life elsewhere because that is important for us.
Sure, sure.
Let's say that we don't find life at all. Well, is that possible because the universe is big? But let's say somehow we realize there's not life out there. So it means you have to be positive. That means that the universe is for us.
I guess
Because
it's right. We win. It's
w- yes, yes, or we can take advantage of the universe. We can trash it. So it's us. But
right.
uh, uh, but if there's a life out there, oh, there's so many considerations that you have to take. You are sharing your space. It could be good, it could be bad, and you have to be careful, not because any life it could be threatening to us, but also we could be threatening other life forms.
Yeah.
So you have to be more careful. So the answer is amazing, and at some point is I think more amazing is to figure out that there is no life out there in so much
Hmm.
space that makes us so important. The, you will see things differently if we realize
Yeah.
that. And if there's life out there, the same way we'll be impressed. So I took in my mind through my career all those two possibilities. And I was amazed. At some point, I don't remember why, I was amazed. So I won't be surprised for
Okay.
the answer anymore. So if
Either way.
somebody find life, I say, well, okay, it's yes or no. Another, no surprise at all. And probably the to be true, probably the most surprising will be not to finding life, because
Yeah.
that will be huge for us. But
Right.
the answer is out there, and I am already impressed. So I'm moving forward to
Yeah.
whatever happens.
We'll see what happens for sure. I mean, do you think it's you know, if we were to come across life at some point, would you think that it would mean that life is relatively common or still uncommon? I guess it depends on the distances that you were thinking about, but
Yes,
um,
yes. I think that probably as many astrobiologists and astronomers that have been thinking on this, that probably microbial life is very common in the
yeah,
universe. But then from microbial life to multicellular life and animals and intelligent life, that's a many huge steps.
right, right,
And that probably less common.
yeah,
And when you take all the possibilities at the stellar, planetary, and biological level, probably planets with intelligent life are very rare. And
yeah,
if that's so, they mean that they are scattered, maybe a few or so in the galaxy, but the galaxy is so huge
sure,
that the distance are so great between stars that probably that's the answer that we are looking for. That life is out there, they're like us, intelligent, but the problem is too far. And that's
right,
why when you look at the historical record of our planet, geological record, I mean, then you don't see that we ever have been colonized by some life form
sure,
in the past. We don't find, a
right,
alien ship next to will you dig a dinosaur or something.
right, right,
so
yeah,
so you don't see that. And I will, if life were common everywhere, I will expect that we have been colonized long ago. I will
yeah,
expect that our planet will be trashed today with
okay,
remnants. All
yeah,
the spaceship probes that have been sent
yeah,
on orbit, also, we see it on the moon. And when we started using radio telescope,
yeah,
then we will be amazed with also noise, not only astronomical noise, but also the noise of all the chatter and of many civilizations that some were not capable yet, some capable as us, and
yeah,
others that are using other communications. So in all stages. So I will expect at least that we will see plenty of evidence if life that were that common. So probably the answer is that there is very far away those intelligent life, and but we have to search.
yeah. I mean, that's a really interesting idea because I didn't think about like in terms of our solar system, if you're comparing it in terms of age to other solar systems within our galaxy, sort of on what part of the timeline would our solar system be to think about like, okay, if there are some other, alien intelligent life out there that could have been here or colonized us, to be able to figure out like how we would fit on that scale of chronologically is very interesting.
Yes, we have our solar system is 5 billion years old,
Right.
and the galaxy is 13 billion years old. So there are many planets that are much older,
Yeah.
twice or so than or should be older, that have probably the opportunity for uh, having life forms everywhere, an intelligent life form. So,
Yeah.
it is expected that we
Yeah.
have many the possibility of many visitors in the past, but it's we don't
No
find
evidence.
evidence of
Yeah.
that. No
Yeah.
evidence of that.
Which is
So,
pretty humbling then to think that if there's, other intelligent life in our galaxy and they couldn't get here and they're much older, what is that? For us, then we have to think about ourselves like, oh, okay, this is a
mhm.
really difficult task to go somewhere. So,
Yes, is that the reason? But it could be other social
right.
reasons, like for
Yeah, of course.
example, that they decided, okay, we are once, let's say, the civilizations get so advanced in the digital, and they produce all this enclosed universe, digital universe, that
Yeah,
they're enjoying. So, and probably those computers and their AI can produce all the possibilities that could be out there, and they look through their big telescope and see those planets with life at different stages, and they decide that's something normal. Let them have their time. We
yeah,
don't need them. We don't need them.
yeah,
We have everything. We can live in planets. We can have stations through stars and live between the stars in their home Death Stars.
sure.
so so they probably say we don't touch anything else because we don't need it. Let's respect.
Yeah,
We have, they are there because somebody respected in the past. Maybe they
yeah,
were the first, and they are just respecting others because they don't need so, and that's it, and that probably be the answer. So
yeah.
why? So there are many visitors, but they're too far, and they're hiding.
that's, that's right. Otherwise,
They're
like, I don't
shy.
want to interact with them. Yeah, it's scary. Yeah.
There we go. Yeah.
Yeah, it's so yeah, it could either be like they're a very morally sound, society of life, or they're just don't care for other reasons, I guess.
Yes, yes. And that reminds me that we are looking at with radio dishes to any signal from them, and even
Yeah,
in the optical, looking through lasers, they are sending lasers. But if you look at that, sending lasers to communicate between other planets, that might be considered rude, pointing a laser at somebody else,
yeah,
especially to
sure,
another entity. So
yeah,
that might, well, we are looking
that's right.
anyway. Let's try it.
That's right. I guess if they point something back at us or they send something after us, we'll know our answer. So,
Yeah, yeah, that could be considered rude, a motive for war or something.
yeah, that's right. Yep, intergalactic conflict. Okay, here we go.
Mhm, mhm.
So how did this Arecibo WoW project come about then? Obviously the WoW signal, you could talk about the history of that, but very, very famous in the world of searching for
Okay.
extraterrestrial life.
Yes. So uh, I have my previous interaction with the wow signal long ago, like checking papers from others about the wow signal. Um, the Arecibo Observatory also had a campaign at some point. I believe it was 2012 to send a reply. That was just a publicity stunt for a TV show.
Yeah.
But they did that, and uh, but I always considered that something like maybe radio frequency interference. It was fun. It was an icon. It's more than that. It was an icon of
Sure.
searching for extraterrestrial intelligence from an old telescope, and I never gave much thought about the world in there.
Yeah.
But we started into 2017 a project to look at red dwarf stars, the activity of red dwarf stars. Red dwarf star we potentially habitable planets. So that's the connection with astrobiology. Even that it was an astrophysical project to look at the stars, but those stars are very active, and their activity impacts their planets. So that's the astrobiology connection. But looking through those stars, the beam size of the radio telescope, so it's the field of view, uh, can is so wide for those distance that you are not only getting the signal from the star, but you also getting the signal for everything from the planets or anything in the background.
Yeah.
And so probably the most interesting thing is that the signal of the star should be in general will be stronger than anything else.
Okay.
Well, so we did that, those observations, many red dwarf stars. We looked through that. And then in 2024, in May or June last year, then I decided that I was thinking about, okay, let's do some synthetic with our data. The telescope collapsed in 2020, so that data was there, not doing anything else. So I wanted to let me try something else, something new with data, look at it in a
Yeah.
different way. So I always had, yeah, through my observations, I always had in my mind SETI, doing, looking, but I was more focusing in the astrophysical part, and I never thought doing SETI. So that was
Okay.
not, so it
Yeah.
was never in my plans. But
Sure.
now that we have that data, the archive data, then I decided, okay, let's look through that. And then how I start. And then I remember the wall signal probably because I saw some uh, programs. There's a documentary that I saw around that time, and there was a podcast.
Yeah.
And then so I have the connection. Okay, let's start analyzing the data, the wall signal style. So using the same procedures that they use and looking for similar signals. So let's do SETI with the archive data.
Yeah.
So I learned how the big ears and other telescopes, big ear was the telescope that detected the Wall signal in the 70s. So I looked through their how the papers and how they did it. So I tried to imitate everything,
Yeah.
the software, to look at our data in a different way.
Sure.
So after starting just 1 month after we started that, we found similar signals. But
Wow.
those
Okay.
but those signals were related to cold hydrogen clouds,
Okay.
and those they are common. Those signals are common. They are stable, so you see now and decades, so they're very, very stable. If you are lucky, depending on the region, you get more or less, and uh, and you have to have your telescope configured a certain way to detect those and
Yeah.
analyze the data in one particular way. So once I analyzed in that particular way, I saw those clouds. I recognize, oh, those are clouds, but they look so much like the wall signal. They just have to be brighter for a moment,
Yeah.
and that's the big difference because they
Yeah.
don't do that. Those
Okay.
signals are constant, and that's it. And so I thought, what mechanisms could highlight those clouds, make it brighter, and for a moment, much
Yeah.
brighter. They have to be much brighter than they usually are. So I thought about different astrophysical process, but there were none that eventually I concluded that maybe there was some way for this cloud to get excited by an external radiation source. This is very complicated and emit a maser-like
Okay.
radiation. I also found a paper that was suggesting something similar through a other astrophysical mechanism. It's not maser, it's super radiance. So, but it's very similar in terms of the signal.
Yeah.
So these clouds could, depending on their properties, on the temperature, and how stable the system, eventually they can like charge up, and they will emit a burst of radiation like a maser, at some particular direction. It's not isotropic. It's not everywhere. So you have to be in that beam, and the beam could be
Right.
random. And so that make is rare for the beam to go through to your direction. And so I have this possibility of the maser flare or super radiance phenomena that have been proposed but never seen before in the hydrogen light. They have been observing other frequency for other uh, molecular species, but never for atomic hydrogen.
Okay.
So that was the big deal. And so we connected everything and just wrote the paper. So we started in May. We found the signals by the similar signals of clouds by July. Then by August we have our first paper, just proposing that this wall signal was caused by astrophysical phenomena. These
Yeah.
clouds getting excited for a moment and emitting a burst of a radio radiation,
Yeah.
and that was it.
I mean, what would like a signal if we actually thought the signal was going to be from some life out there in space? What would that signal look like in comparison to just something that's like an astronomical phenomenon?
There won't be any difference at all.
Okay.
So in your perspective, you will still see the same thing.
Okay.
So it looks like a maser. So maser is the same thing as a laser, but in the radio spectrum.
Okay.
So you see a maser,
Right.
but the physics that emits that could be different. It could be
Okay.
actually a maser, a natural maser,
Yeah.
which we know for other molecular species, not for hydrogen, but we have seen that from space. So it could be natural maser. It could be an artificial maser.
Yeah.
So that's
Yeah.
like a laser. We have masers on Earth. We build
R-
masers on Earth.
right.
I,
Right.
I mean that in that particular frequency. Yes, artificially we build them.
Yeah.
So and there's also this process of super radiance, which is something it's a different mechanism, but it still emits like a maser.
Okay.
So you have three things. Two are natural, one is artificial,
Yeah.
and you will see the same signal. So
Okay.
that's why we cannot we this is only a possibility,
Yeah.
a possibility. The thing that we are more sure it was that no was a terrestrial radio frequency interference.
Yeah.
We try everything. That was the first thing we tried once we got the attention with the first paper, and the scientists that work at the observatory just we got their attention. They just send their data, and we were surprised that that was surviving data from the 60s and the 70s, and
Yeah.
that data was hidden because they were scattered in different houses of volunteers that worked at the telescope. So with that data, we were able to reanalyze the web signal and try to look at first. We tried to look, maybe this is something radio frequency interference, and now we have the data to verify that.
Sure.
So, and we tried every possible way, even the absurd one, trying to consider, for example, well, maybe nuclear explosions through that time.
Yeah.
They are related. Maybe it was some auroras related or the sun related. And we looked through the newspapers through all that time, months before and after, for practice, military practice, events, astronomical events, people playing in that area. So,
Wow.
so airplanes and helicopter, but there was not much to that. Satellites that are in that zone, and we did a computer model also. We can inject random noises of different levels just to try to imitate as to see if the somehow the pipeline of the telescope could imitate similar signals. We created so many different signals, but nothing like the world signal. So eventually we realized, okay, no way. This is something coming from space.
Okay.
I think that's the best thing we can say now, that we are so sure that this is something from space, astrophysical, for whatever reason. So, but
Yeah.
the particular reason, yes, we believe is something natural, but we cannot say to other, because we, for that we need proof, and
Yeah.
we don't have proof. So
Well, I mean,
this is a hypothesis.
that's the interesting question about this because, like, let's say, we did get a signal from some life form in space. How would we know it's life in space versus something natural?
Yeah, in this case, the telescope didn't have enough time observing. This
Yeah.
was a telescope working in a drift mode, so the
Ah.
telescope was using the rotation of our planet to point.
Yeah.
So it was passing through the source of that radiation. It was a moment. It was 72 seconds. So that's the
Yeah.
famous 72 seconds. Why 72 seconds? It was just because that's the time it took the telescope to pass through, because of the
Right.
beam side was wide enough to keep it in that space through in view through that time. So that's not relevant at all. It's nothing a property of the
Sure.
signal. The signal could be there or hours after it was detected, or hours before it was detected, because something interesting is that telescope had two beams. So two cameras observing very close. So it just got the signal got in one beam and not in the other. And we don't know which beam in particular. So it could be that it just got into the first beam, but when the other beam was passing through, it turned it off. There was not in the
Yeah.
other beam. Or when it was passing through, it just got in the last beam and it's moved on. It just appeared in that beam. So it turned it off and on between the beams, and that's a 3 minutes change between those two.
Sure.
So probably it didn't last long. If it was before or after on, probably it just lasted minutes or hours and then just stopped, because the telescope, at least it went back to that zone 48 hours later.
Okay.
And it was not there anymore.
Yeah.
So it was a flash. So for answering your question, what would we need? So this was not much information. It
Yeah.
was just a bright source, and that's it. But if the telescope were pointing, as usually they do, just point and keep pointing, Earth rotation permits, looking at one particular region, then that you have hours or so of observing, probably is this something a artificial source. It will be probably encoding some information. It will be flashing, changing. So that's what we call modulation. It will be
Yeah.
modulating, because there's some information there. Because if it's not doing that, then probably it will be very hard to just to say, okay, this is artificial or not.
Yeah. I mean, if we were to come across or life somewhere around space, what do you think would be the most likely way we would do that? Would it be through signals or would it be through something else or
Okay, I think that the answer is next door, Mars.
Okay.
Because there's a big answer waiting for us there.
Right.
And people are worried that if we send uh, missions to dig into Mars and not finding life,
Hmm.
they will be mad. We're not finding life.
Yeah.
but but there is an answer anyway. For example, if we dig into Mars, and you have to dig, so that's future missions. We cannot do that. Probably a few meters down or more, and we have liquid running water that should be there at some points through Mars, many areas. Liquid water, I mean running water, and we can, if we look through that liquid water, which means it has a nice temperature, at least to be liquid with all the ingredients of the rock around it. So that's perfect habitable conditions.
Yeah.
But imagine we got a sample of that, probably through many samples through the planet. and we don't find any life at all, not even microbial life, simple life forms at all. That will be amazing
Yeah.
because perturbing because wait. So this is telling me that life is so difficult that even on Mars didn't start life.
Yeah.
Wait. There's more. Mars is close to us. We exchange material. We have meteors from Mars. Probably Mars have meteors from Earth. So we exchange material. So probably at one point terrestrial life migrated by force to Mars. And even so, there's no life there. That will be something big. And people will say, wait. Is that so hard? And this even a solar system. And it just happened on Earth. What are the possibilities in other systems?
Yeah.
Maybe that uh, some people will get frustrated with that.
Yeah. Big disappointment. Yeah.
Yeah, disappointment. But if we find life, then happy. We say, okay, we find life. Yes, we expected that, but your question has been answered. But what's your next question after that?
Right.
Is that life related to Earth?
Yeah.
Is that terrestrial life that migrated long ago, or maybe that's life that started on Mars, and what life started on Earth was life from Mars. So we are
Yeah.
everybody's Martian. So that would be your big question. And but so you see, the two answers are amazing, are huge and amazing discoveries. No matter what the discovery, probably the more perturbing is not finding life in such
Sure.
conditions.
Yeah. Yeah.
And and then the answer is there on Mars.
Yeah.
So probably I think that the final answer for this question of life, yes or no, could be Mars. And if we don't find life on Mars, that will be tantalizing, but it doesn't tells you that it's impossible somewhere else. But it will be revealing. And that's the big answer. And that's the answer that we can verify.
Right.
We can get those samples back on Earth, and
Yep.
But the other way, looking through life in extrasolar planets or exoplanets through the atmosphere, we will be fighting for a long time. We
Yeah.
could be detecting biosignatures, and we will figure out eventually, oh, we have a process that could do naturally that change in the atmosphere. So we believe that oxygen in the atmosphere for an exoplanet was the key to tell if a planet has life form or not. But now we realize not. There are other processes that could put a lot of oxygen in the atmosphere on exoplanets. So and every time, oh, but maybe this combination or maybe the other, and that's it's quite complex. And you will be far away from your source, and we will be saying maybe yes or no for a long time, for decades, for example, and that will be a big fight. The only way that I can see that we get a signal, that a biosignature from far away, and we can say definitely this is it. It has to be some techno signature, some radio or optical signal that we can monitor for a long time and see the patterns changing just with information that we can
Yeah.
decode, and that's and for a long time. And we will then realize that definitely that's no way for a natural process to emit something like that, where the signal encodes information, even information that we can understand or not understand, but we will be able to tell there is some patterns there that are not random, like we do in languages, and we different algorithms that we look through a different scramble of text, and we can just put that through a computer and tell about if there is a pattern there that tells you this is random oh no, this is something information. We cannot decipher it yet, but at least we know it was created with some particular pattern that it looks like a language or so. That looks like information. So that's the only way. So we should do every possible way to look for life, even if that life is far away, because as I said before, the answer yes or no, and to say no, it will be a forever, but at least detectable within our current instrument. That's something that we will need to answer anyway.
Yeah, it's the never-ending question, I suppose, for now. So,
Yes,
um,
yes.
and also, I think just says a lot about us as like a species too, where like this is something that starting as children, people are thinking about like, is there something out there? Like we care so much about knowing that we're not alone. Um, has that question kept you up at night at all when you think about like you're doing all this research for years and years and years, and you're wondering, is there going to be something that we're going to come across at some point, or that's going to finally definitively prove there's life beyond Earth, or
No, I think that once I realized about the yes or no question with Mars, that was a big change in my mind. But I can tell you that I was surprised in 2010 when the first announcement of a potentially habitable planet. That was the first announcement. There was something related in 2007, but it was not a big announcement. But this in 2010, NASA announced it, the first one, and yes, that kept me awake at night. Once I heard the news that night, I didn't sleep because I was thinking, "Oh, for real, are we finding those planets now?" And well, now we know that that was a false call. That
yeah.
there's no planet. There was not that planet. It was something related to the stellar activity that got confused the instrument. But so I am now open to any possibilities, and I said I'm not surprised for either. I am more surprised for for things that I don't expect,
Okay.
because I
Yeah.
expect that the answer is yes, no, that's easy.
Right.
Now I will be more surprised for things that I don't expect. And I mean astrophysics and in life. If, for example, you tell me, oh, there are these things, black holes in the universe, and I will say long ago, or say, "Nah, that's something not possible. That's strange. I never seen something like that." So, okay, now we know they exist. But you tell me long ago about life out there. I said, that's something that we know exists, life here, intelligent life. That's not surprise at all. That's not surprise. Tell me something that will amaze me. Oh,
Right.
there's a square planets out there. Oh, that will be amazing. But that's in terms of astrophysics. But if there life on Earth is amazing, you see, I get surprised every time I look at Nat Geo documentary or some other program of showing different from microbial to animal life behavior and how they live and the features and characteristics, and looking through other life forms, that could be amazing. So I wonder what surprises are there, not the things that we can think of, but the things that we are not aware and will be surprised. And and if you include intelligent life, wow, what no, I would say what not is surprising. It could be something totally amazing, totally, and this is the right moment for the right word, alien for us.
Yeah. We'll see what happens. It's I guess it's part of the fun is that there's lots of things we don't know yet, so that's what keeps things interesting.
Yep.
But What are you currently working on these days then?
Well, I am okay. The Arecibo Wall project
Yep.
t- took me a chunk of my life
Yeah.
and unexpected because, as I said, I was planning to look through wildlife signals in our data, but then we have the original data from the wall signal, so started reanalyzing and have a revision of the data of the
Yeah.
wall signal of the properties.
Okay.
For me and our team, that was surprising because after almost 50 decades, new properties of the wall signal. So what happened? So we got that, and then through this process, we also had an explanation that was not part of the plan. We got because we did a revision of the properties, and we realized that the signal was stronger than previously believed, so strong that even small telescopes could detect it.
Wow.
A small telescope? I can't do that. So, so we started this program to using small telescopes that people can buy, and people can buy this telescope about 500. So the idea is because for the web signal, even there is a strong event, should be very rare and very difficult, and that's why probably it was detected once. You have to
Yeah.
be monitoring all sky. So that's the way to have many small telescopes that we can buy, build, and other people can join
Yeah. Just
also
spread them around.
and work together to have a network small telescope. You will need about 300 to 500 of those through the planet, and then you will cover a full sky 24
Yeah.
7 7. And there are many more thousands of astronomical aficionados, amateur astronomers that spend 2000 or more for their telescope,
Yeah.
so this is cheap for them. So
Definitely.
we submitted a proposal, and we got that proposal to build a network of starting from our hub here in Puerto Rico, and making it across, but then and having a workshop, and we will give some workshops on how to assemble, because it's something, the hardware is nothing special in particular. uh, they don't come to assemble together. No, they're different parts, and we selected and tested different parts that work together. The key here is the software, to software that connect the telescope to work as one, looking to the whole sky. That's the key, and that's what we're building. So that was also unexpected. Unexpected. We also, so that's a, let's say, a spin-off of the Arecibo Well project. So eventually, I will go to the initial idea of the project is
Yeah.
looking for wildlife signals in our archive data. And I
Right.
mean the data that we took, but also decades of data from the Arecibo Observatory that are now preserved and just be to reanalyze in a different ways for others. So that will be finally the project that I will be doing. Meanwhile, I'm doing other projects related to in theory on astrobiology, especially astroecology, how to measure habitability. And
Yeah.
once we detect life, what's the next steps in terms of recognizing and understanding this life, how to search for life in ecosystems like Mars or beyond. But that's in a more theoretical aspects of that. So
Awesome.
that
And
keeps me
what's
busy.
Yeah, yeah, sounds like you're gonna be busy for a while. Yeah. And, how can people follow you and keep track of your work?
So probably d- i- in X was the best way,
Okay.
but I still have that account, and I can share news there as
Yeah.
Prof Abel Méndez,
Yep.
Professor Abel Méndez, and they all can but I am using now more Blue Sky.
Okay.
So
Yeah.
in blue sky, you can see more. But I try to share things in both things, but I am not that active as before because
Right.
I have all the tools built to connect to Twitter,
Yeah.
and it was easy for me because that was looking through my news system, and then
Sure.
just click share, and it will transfer that to Twitter, and that was very easy. I don't have that anymore. They
Yeah.
eliminate that, and
Yep.
so that's why it's harder now. But
Yeah.
we
Makes
also
sense.
have the page, our website page, phl.upr.edu. That's our research page, and we usually post their events, and we have a particular page for the Arecibo Wow project.
Great. Well, thank you so much for coming on and talking about this topic that every human being on the planet basically is interested in the idea of searching for life. So appreciate all your expertise on this.
Okay, thank you for the invitation, Ben. I appreciate, and let's see what happens.
Yeah, well, we'll see what happens. That's right. Maybe we'll get a signal tomorrow. That's right.